Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics, Extended Physics. And today we have set our hearts to solve a paper 2 of this subject. This paper 2 is a multiple choice paper, and the paper we have selected is October November 2022 2-1 paper. This paper 2 belongs from the Zone 1. The time allowed for this paper is 21 minutes, 45 minutes, sorry. And let's start. And here we go. This is the paper. In this video, I'm going to present you the solution of this paper to the best of my knowledge and my abilities. The time allowed is 45 minutes, and the total marks for this paper are 40, and in this paper the g value will be taken as 10 meter per second square. But now in our latest papers, since from the 2023, the g value is taken as 9.8 meter per second square. Okay, so the question number 1 is showing up on your screen. He says, which measuring instrument is used to measure the diameter of a thin metal wire? The diameter of very thin metal wires is always measured with the help of the micrometer screw gauge. So we use the micrometer screw gauge. I think the D is the option, sir. D is the right option. So we will go to the next part, and the next part is question number 2. A car starts from rest. The table shows the readings from its speedometer every 10 seconds. Okay, so here we have an increment of 10 seconds, increment of 10 seconds, increment of 10 seconds, increment of 10 seconds, 10 seconds, 10 seconds. Now here the speed has increased by 4, and here the speed has increased by 4. Here the speed has increased by 4. Here the speed has not increased. Here the speed has not increased. Here the speed has not increased. So from 0 to this, so in the first 20 seconds, you see, during the first 30 seconds, you can say, uh, up till here, the speed has increased. In every 10 seconds, there is an increment of 4 meter per second square. That means the speed of the car is increasing. That means the car is accelerating. And the acceleration is uniform. It has a certain acceleration, but that is not 0, but it is accelerating. But from 30 to in the last from this to this, the speed has become constant. Okay, so in the last 30 seconds the speed is constant, so either the B or the D is the choice. It has, in the first 30 seconds, it is accelerating, and there is a certain value of the acceleration, you can see. So non-zero acceleration and constant speed. So I think question number 2D is the right option, sir. He says, which property of an object is a consequence of the effect of a gravitational field acting on it? Density, no. Mass, no. Volume, no. Weight, yes. Weight is due to the gravitational field acting on a body. So question number 3D is the option. That's the right option, sir. Question number 4 is showing up on your screen. The diagram shows the dimensions of a solid rectangular block of metal of mass M. You see the length is P, the width is Q, and the height is R. So the volume will be length multiply width multiply height. And he says, which expression is used to calculate the density of the metal? The density of the metal is, the density of the metal is, mass divided by volume. So mass divided by volume, I think B is the right option, sir. Question number 4, B is the right option. Question number 5. The wheelbarrow has a weight W of 140 Newton. Which vertical force F is needed to support the wheelbarrow in the position shown? Okay, so here you have that pivot. This is your pivot. Okay, so if this is your pivot, then this force W, the weight of the wheelbarrow, is trying to produce a clockwise moment, and this force is trying to produce an anti-clockwise moment about the pivot. So the weight multiply its distance from the pivot, and that perpendicular distance is this one. And this perpendicular distance will be 1.4 meter minus 1.4 meter minus 0.8 meter, and that will be 0.6 meters. So this will be 0.6 meter. So the moment arm for the W is 0.6 meter. The moment produced by the W, which is clockwise moment, that will be the weight multiply its moment arm. And this force, which is trying to produce anti-clockwise moment, it will be force multiply its moment arm. Its moment arm is this. Moment arm is the perpendicular distance between the line of action of the force and the pivot. And for F, that moment arm is 1.4 meter. According to the principle of moments, the clockwise moment is equals to the anti-clockwise moment. So F multiplied D1 will be equals to F multiplied D2. So W, which is 140 Newton into 0.6 meter, that will be equals to F multiply 1.4 meters. So F will be equals to 140 multiply 0.6 divided by 1.4, and that will be 60 Newton. 60 Newton, do we have that option? Yes, sir, we have this option. This is the A option, question number 5. A is the right option, sir. This is how we have solved it, and this is the question. Okay, so A is the right option. The next question is question number 6. A car is traveling around a circular track at a constant speed as shown. In which direction is the resultant force on the car? Because the car is moving in a circular track, and whenever you move in a circular track, the resultant force is always directed towards the center of that circle. So this is the direction of the resultant force. Question number 6, B is the choice. Yes. Okay, so the next question is question number 7. The diagram shows part of how the hose used by a firefighter. Hose means the pipe. So the water which is here, its speed is 1 meter per second. The water which is here, its speed is 6 meter per second. 15 kg of water flows through the hose each second. Which force is applied to the hose by the water? That's question number 7. You know the force multiplied time, that is impulse, and the impulse is also the change in the momentum. So force multiplied time is equals to the mass multiply final velocity minus mass multiply initial velocity. F is the question, time is 1 second. So 15 kg multiply 6 meter per second minus 15 multiply 1 meter per second. And so this will be F equals to 90 minus 15, and F will be equals to 75 Newton. 75 Newton, that is the B option, sir. So question number 7, B is the right option, sir. This is how we have solved it. And we go to the next question. That is question number 8. He says, brakes are used to slow down a moving car. Into which form of energy is most of the kinetic energy converted as the car slows down? When you apply brakes, your kinetic energy converts into thermal energy, into heat. When you try to overcome that friction between the tires and the road, between the disc and the brake pads, then the kinetic energy converts into the heat, into the thermal energy. So I think C is the option. Question number 8, C is the right option, sir. Question number 9 coming up on your screen. He says an object has kinetic energy of 200 joules. A constant resultant force of 190 Newton is applied in the direction of its motion through a distance of 10 meter. What is the final kinetic energy of the object? You know the work done is equals to force multiplied distance, and the work done is equals to the gain in the kinetic energy. This is a very important relationship. Two formulae for the work done. Initial kinetic energy is 200 joules. The work done is force multiplied distance. So 190 Newton multiplied 10 meter, that is 1900 joules. Final kinetic energy will be the initial kinetic energy plus the work done. So 200 joules plus 1900 joules, that is 2100 joules. 2100 joules. D is the right option, sir. Question number 9. D is the right option. So this is how this work is done. You can pause the video. So we are going to the next question, and the next question is question number 10. He says the statements describe what happens when the power of a machine is increased. You see, the power of the machine is increased. Power is the work divided by time. So if you want the power to increase, that means either the time should decrease or the work should increase. The work done in a given time decreases. That's the wrong statement. The work done in a given time increases. That is right statement. The time taken to do a given quantity of work decreases. This is also right statement. The time taken to do a given quantity of work increases. That is wrong statement. If you want the power to increase, either in the same time you increase the work done, or for the same work done, take less time to do that work. So I think 2 and 3 is the right option, sir. So C is the, which statements are correct? 2 and 3. So C is the option, sir. Question number 10. Let me check. Question number 10, question number 10, C is the right option, sir. Okay, so we are going to the next part, that is question number 11. Here we have, he says a manometer containing water is used to measure the pressure of a gas supply as shown. The density of the water is 1000 kg meter per meter cube. What is the pressure of the gas supply? You see here you have the gas supply, here you have the atmosphere. The gas has pushed this level of the water, and that means the gas pressure is more than the atmosphere. And how much more this is, you will find the difference of this height. So this difference is 40 minus 10, that is 30 centimeter. Then I will convert this into, you can say, I will convert this into pascals, and then I can say this much, the gas pressure is this much more than the atmospheric pressure. So very simple. Question number 11, and here we go. So in the question number 11, the difference of the height in the levels of the water is 40 minus 10, that's 30 centimeter. When you convert this into the meters, you divide the 30 centimeter with the 100, that is 0.30 meter. So the density of the water is given, which is the liquid in the manometer, that is 100 kg per meter cube. So the pressure of that due to that height of the water is rho gh. That's the formula for finding the pressure of a liquid. So 100 into 10 into 0.30, that will be 3000 Pascal. So the pressure of that gas supply is 3000 Pascal more than the atmospheric pressure. So the pressure of that gas is 3000 Pascal above the atmospheric pressure. So I think C is the option, sir. Question number 11. C is the right option. Okay, so we are going to the next part, and that is question number 12. He says a fixed mass of a gas is trapped in a container. So the mass of the gas is not changing. The temperature of the gas is increased, but the volume of the gas is kept constant. This is very important wording. The volume is constant. So when the volume is constant, the pressure is directly proportional to the temperature. If the temperature of the gas will be more, the pressure of the gas will increase. If the temperature will be low, the pressure will be also low. How does this change affect the average kinetic energy of the molecules and the pressure on the walls of the container? You see, when you will increase the temperature, the speed of the molecules will increase, so the kinetic energy will increase. So the average kinetic energy will increase and the pressure will also increase. So I think increase. So I think A is the option. Question number 12. A is the right option, sir. Question number 12, A is the right option. Now we have question number 13. He says, which row correctly describes boiling and evaporation of the water? In the boiling, yes, the bubbles are seen. and no bubbles. Okay, so either it's A or B, because in the boiling the bubbles are seen. Evaporation occurs at the surface only. That is a true statement. So A is the best answer. Bubbles seen in the boiling, yes. Occurs throughout the water, no. Evaporation occurs at the surface only. So question number 13, I think A is the right answer, sir. Then we have question number 14. He says the diagram shows a liquid in glass thermometer. Which change increase the sensitivity of the thermometer? If you want to increase the sensitivity of the thermometer, you have to decrease the the then you have to make narrow the capillary tube. You need to make it narrow. You have to decrease its diameter. That will make the thermometer more sensitive, because when its cross-sectional area is smaller, that tube, the capillary in which the mercury thread moves, for the same rise in the temperature, there will be a larger change in the length of the mercury thread. That's why it will become more sensitive. It will cover longer distance. It will have larger expansion for the same rise of the temperature. So a narrow capillary tube, yes, that is true. A wide capillary tube, no, that's totally wrong. Thicker glass around the bulb, that does not affect the sensitivity. Thinner glass around the bulb, that does not affect the sensitivity. Question number 14, I think A is the right option, sir. That is true. Okay, question number 15. The diagram shows a liquid in glass thermometer with a uniform capillary tube. So when the temperature is 0, this is your L naught. That means the length of the mercury when the temperature is 0. When the temperature is 100, this is the L, what we call it, L100. What does that mean? The length of the mercury column when the temperature is 100 degree. Now, when the length of the mercury is 64 plus 8, what is the temperature? So this is the question, very famous question, very famous type of question. So let me show you. L theta minus L naught divided by L100 minus L naught is equals to theta minus L naught is 0 degree centigrade. It represents 0 degree centigrade. And 100 minus 0, because L100 means 100 temperature, L naught means 0 degree centigrade. So L theta will be 64, this 64 plus 8. So that will be something like 72 minus 8 divided by 88 minus 8. The equals to theta by 100. So it will be 64 divided by 80 equals to theta by 100. So 80 theta will be equal to 64 into 100. Theta will be 64 into 100 divided by 80. And that will be equals to 8 into 10. And that is 80 degrees centigrade. So this length is basically representing 80 degree centigrade. So I think question number 15, B is the right option, sir. This is how this is done. Question number 15, B is the right option, sir. B is the option. Question number 16. Four thermometers with their bulbs painted different colors are placed at equal distances from a radiant heater. Which thermometer shows the slowest temperature rise when the heater is switched on? You see here the worst, the worst infrared absorber is shiny white. So this temperature will show the slowest rise, the slowest temperature rise, because the shiny white surface on the bulb, that is the worst absorber of the infrared rays. So it will show the least rise in the temperature. So I think question number 16, D is the right option. Question number 17, a wave source produces 300 crust every minute. So every minute, 1 minute means 60 seconds. You can find out the frequency from here. The waves has a speed of 300 meter per second. What is the wavelength of the wave? Okay, so that is question number 17. The frequency, because they are producing how much? I think 300 or 3000. Yeah, they are producing 3000 in 60 seconds. So the frequency is 50 hertz. The speed is 300 meter per second. The wavelength is the question. You know the wave equation, V is equals to F lambda. So lambda will be equal to V divided by F, and that is 300 meter per second divided by 50 hertz, and that is 6 meter. So the wavelength is 6 meter. Do we have that here? C is the option, sir. Question number 17. C is the right option, sir. This is the solution. C is the right option. Question number 18 is showing up on your screen. He says the diagram shows two sets of the wavefronts in a ripple tank. A student makes two statements about the waves. So here the waves are coming, they have a barrier in the path, so reflection of the waves will take place here. When the reflection takes place, the direction of the wavefronts changes, the frequency do not change, the speed also do not change, the wavelength also do not change. Only the direction of the waves changes. Here, the wave direction, the waves are entering into a portion of water where the water is shallow. So whenever the water waves enter where the water is shallow, their speed decreases, their wavelength decreases, the direction changes, their frequency do not change. So a student makes two statements about the waves. When the waves reflect from the barrier, the direction changes, but the wavelength remains the same. This is a true statement, sir. When correct statement, I mean, when the waves refract as they enter the shallow water, the direction remains the same. This is wrong. Their direction changes, but the wavelength changes. Wavelength changes, speed changes, direction changes, frequency do not change. This second statement is basically wrong. He says which statements are correct? Statement 1 and 2, no, the statement 1 only. The statement 1 is correct, the statement 2 is not correct. So question number 18, B is the right choice, sir. B is the right choice. So if you want to see that question, the whole of the question, so let me show you. So hopefully now this is showing up on your screen. So B, only the statement 1 is correct. Hopefully I think that you know what is the reflection of the water waves and what is the refraction of the water waves. Okay, so we have here question number 19 coming up on your screen. Okay, so a composite block is made by joining together three transparent materials. The diagram shows a ray of light passing through the composite block. Okay, so material one, material two, material three. So light is entering from one block in one material to second material to third material. Okay, so if I draw a normal here, suppose I draw a normal here. So what will happen? What you will observe that it has banded towards the normal. So here the speed is slow. The speed is slow as compared to this material one. Here the speed is slow. When it entered from the material number two to material number three, it has banded away from the normal. So here the speed is fast. Okay. So that means, and this banding tells me this is lot fast. So the speed is slow here. This is here in this material, the speed is faster than this material. And in this material, you see the speed is a lot fast. So the slowest, which list gives the three materials in order of the speed of light in the materials from slowest to fastest? So I think the slowest speed is here, it is fast. I think here the speed is fast. And here the speed is slowest, and here the speed by this banding act I say can say you the fastest here. Okay, so I think 2, then 1, and then 3. So we are writing from slowest to the fastest. I think 2, 1, and 3. C is the option. Question number 19, C is the option. This question is not easy. It needs a lot of concept and common sense. Question number 20. An object is placed 30 centimeter in front of a plane mirror. So for example, if this is a mirror and this is your object, this is your object, then the image will be also at the same distance, this distance, the same distance, it will be behind. So there you have your image, so for example. So if this is 30, then this will be also 30. So this is 30. So the image will be also 30 centimeter behind the mirror. So the distance between the object and the image will be 60. Okay, which statement describes the image of the object? And the image is the same size, that's true, and 30 centimeter from the object. No, from the object it is not 30. From the mirror it is behind 30 centimeter. The image is the same size and 60 centimeter from the object. From the object, the distance of the image is 60 centimeter. Then he says the image is smaller. No, the image is not smaller. So C and D is wrong. The image is not smaller. The image has the same size as that of the object. So question number 20, I think in the question number 20, I think B is the right option, sir. Question number 20, B is the right option. He says a ray of light, question number 21. A ray of light is shown onto the surface of a mirror. Which two angles represent the angle of incidence and the angle of reflection? You see, the angle of incidence is between the incident ray and the normal, and the angle of reflection is between the reflected ray and the normal. So this is your angle of incidence, and this is your angle of reflection. 2 and 3. So I think C is the option, sir. Question number 21, C is the right option. Question number 22, he says the speed of the sound in the air is 330 meter per second. How do the speed of sound in concrete and water compare with this speed? Okay, so the speed in the concrete will be more than this speed, and the concrete in the speed of the sound in the water will be also more than this. So greater, greater, a very tricky sentence which he has used. How do the speeds of the sound in concrete and water compare with this speed? Okay, so the concrete speed, the speed of the sound in the concrete will be more than this speed. Speed of the sound in the water will be also more than this. So greater, greater. Question number 22, A is the right option, sir. Okay, question number 23. This is, what is the speed of the microwave in the air? All the electromagnetic waves travel with the speed of the light, and that number you have to remember is 3 expo 8 meter per second. So I think question number 23, I think C is the option, sir. Question number 23, C is the right option, sir. Okay, so we are going to the next part. That is question number 24. An observer stands at the finish line of a 100-meter race. He wants to time the winner's run. He starts his stopwatch as soon as he sees the smoke from the starting gun instead of when he hears the bang. What is the reason for doing so? Because the light reaches him immediately and the sound reaches him later, because the speed of the sound is very, very fast as compared to the speed of the sound. Light travels much faster than the sound. This is a right statement. There is a risk he might respond to an echo from a wall. Humans react slower to sound than to light. No, human reacts more quickly to sound than to light. These all statements are wrong. Only right statement is A part. Question number 24, A is the right option, sir. Question number 25, which statement is not a method of magnetizing an iron bar? Place the bar next to a magnet and hammer the bar. When you place some iron bar near a magnet, it becomes a magnet due to the magnetic induction. So A is a method. Place the bar inside a solenoid, switch on alternating current. You know, this alternating current is not used to make the magnets, it is used to demagnetize. So this is not the method, okay? So he says place the bar inside, iron bar I mean, inside a solenoid, switch on an alternating current in the coil and gradually reduce the current. So I think this is not, this method is used to demagnetize the magnet, not to magnetize them. So yes, B is the right option. This is not a method to magnetizing an iron. C option is place the bar inside a solenoid, switch on a direct current in the coil and gradually reduce the current. You don't have to reduce the current, but when you use DC current, it magnetizes the bar. This method is used to magnetize. We are looking for not method which is not used to for magnetizing iron bar. So stroke the bar repeatedly with this method is used to magnetize. So this method, which was given in the B option, that is not used to magnetize. It is used to demagnetize. So we are looking uh, is not a method for magnetizing an iron bar. So B is the right option, sir. Question number 25. B is the right option. Okay, question number 26, he says the diagram shows a circuit containing a variable resistor connected to a variable power supply. The table shows the currents for different values of the potential difference and the resistance. Okay, so we have different values of the potential difference and the resistance, and then we can find the current. You know, the current will be equals to V divided by R, so I can find out I1, I can find out I2, I can find out I3. What is the order of the currents from the smallest to the largest? Question number 26. So let me show you, I've done this on a paper. Okay, so here we have question number 26. So I1 will be equal to V1 divided by R1, 3.6 volt divided by 12 ohm, so that is 0.3 ampere. I2 will be equals to V2 divided by R2, that will be 1.2 volt divided by 12 ohm, and that is 0.1 ampere. And I3 will be equals to V3 divided by R3, and that is 3.6 divided by 6, and that is 0.6 ampere. So the smallest one is I2, then I1, and the largest one is I3. I2, I1, I3. I2, I1, I3. I think C is the option. Let me check again. I2, I1, I3. I2, I1. So C is the right option, sir. Question number which one? Question number 26. C is the option. Question number 26. C is the right option. And this is how we have found this. And the statement was, what is the order of the current from the smallest to the largest? So I2, I1, I3. C is the option, sir. Question number 27, he says, which diagram shows the electric field pattern around a positive charge? So from the positive charge, electric field lines fan out. So I think A is the right option, sir. Question number 27, A is the right option. So he says a negatively, question number 28, a negatively charged plastic rod P is placed above a potentially charged plastic rod Q. What are the directions of the electrostatic forces on the rod P and on the rod Q, sorry. So this will be attracted upward and this will be attracted downward. Okay. This moves according to the electric field. The electric field is going from positive to negative. So the positive, it will go in this direction. This is negative, it goes opposite to the electric field, that will go downward. So the electrostatic force on the rod P will be downward, and the electrostatic force on the rod Q will be upward. So I think B is the option, sir. Question number 28, B is the right option. Question number 29. A lamp rated 12 volt 2 ampere is switched on for 1 minute. How much energy is transferred by the lamp, and the answers are in joules. So the power, the energy is equals to IVT. The energy is equals to IVT. I means the current, V means the voltage, and T means the time, but the time must be taken in seconds because we want the answer in joules. So 2 multiply 12 multiply 60, that is 1440 joule. 1440 joule, and that means D is the right option, sir. Let's check question number 29. Question number 29, I think D. Question number 29, D is the option. Let me show you the solution again. And this is 1440 joule. And D is the right option. Question number 29. Question number 30 is showing up on your screen. An alternating current AC power supply is connected in series with the resistor R and diode. You see, when which graph shows how the voltage V across the resistor R varies with the time. So when the conventional current will come in this direction, this diode will let the current flow through it. And obviously, the current will flow in this direction through the R. But when the current will try to come in this direction, you know, this diode will not let the current flow through this, through itself, because now the direction of the conventional current will be opposite to its arrow. So the diode will be backward biased, and it will not let its resistance will become very high, and it will not let the current flow through it. So during half of the wave of the alternating current, there will be voltage in the R, and during the half wave of the alternating current, there will be no current, no voltage in the R. So let me see which graph shows the best. Okay, so I think in this, you see, during the half wave of that current, alternating current, there is voltage in the R, and during the next half wave of that alternating current, there is no current, there is no voltage, and then again you half wave you have, then no voltage, then again you have. So this is the C is the best representation of the voltage which is in the R. So I hope you understand this, and let me check question number. This is question number 30. We think, what is this option? C option. Question number 30. C is the right option, sir. Okay, so we are going to the next part. That is question number 30. And he says, a student makes 4 resistors using different pieces of wire. The wires have different diameters or lengths. All the pieces of the wire are made of the same material. Which piece of the wire will make the resistors with the largest resistance? Okay, so here we have the diameter. I can find the radius, then I can convert this into centimeter, and here we have the length. The resistance of a wire is equals to the resistivity multiply the length divided by the cross-sectional area. And the cross-sectional area, here the cross-sectional area is not given. So instead of using the cross-sectional area, the cross-sectional area is pi r square. So pi r and square. So I will find out. I will keep the row as row because the density is not given. When I will try to compare, all of them have this row with them. So don't worry about this row density. We do not have its value and it does not matter. So let me show you how this is done. Okay, so here we have the resistance one will be rho L1 by area 1. So its length is 10. Its radius will be 0.4 divided by 10 centimeter. And now I will take it square. And my answer will be 1989.4 density, rho, and ohm. Okay, R2 will be equals to rho multiplied 17. Its length is 17 divided by pi divided by 0.4, and it's 10 divided by 10 and square, and that will be 3382.0 rho and ohm. All of them will have this word rho, which is the density of the material, which is the resistivity. Sorry, I said density. It is the resistivity. Resistivity. Here, when I was trying to explain you, I used the word density. This is resistivity. Sorry. Okay. So then I will find out the R3, that will be rho L3 by A3, that is rho into 10 pi 1 divided by 10 whole square, and that will be 318.31 ohm resistivity ohm. And because all of them will have this resistivity, so you don't have to worry about this resistivity thing. So R4 will be equals to resistivity multiply the length of the fourth resistor divided by its cross-sectional area. So that will be rho and 17 divided by pi r square. So that is 1 divided by 10 and whole square. And that will be 541.1. So the largest resistance is this one, 3382.0 rho ohm. Because all of them have this rho, we don't know the value of the rho. So when you compare them, the value of the rho will not be affecting because they all are made of the same material. So they all have the same resistivity. This rho stands for the resistivity. So B is the option. So B is the option. A lot of calculation is involved in this. Question number 31, B is the option, sir, which is the right option. This is the solution I have done. Okay, so we are going to the next part, and that is okay. That is okay. Which diagram shows a circuit containing a battery, a fuse, and a buzzer? Okay, so this is the symbol of a belt. This is the symbol of a belt. This is the symbol of a LDR. This is the symbol for the fuse. Okay, so these two are LDRs. These are not fuse. And here we have fuse. Here we have fuse. This is the symbol for belt, and this is the symbol for buzzer. Okay, so buzzer, alarm, you can say. So D is the right option, sir. I think question number 32, question number 32, D is the right option. You should know this is belt, this is buzzer. And this is the symbol for the fuse. This is the symbol for the light dependent resistor because it said fuse and the buzzer. So D is the right option. Question number 32. Okay, so this is a tricky question. The diagram shows a network of logic gates. So this is a NOT gate, this is a NOT gate, and this is OR gate, and here we have the out, and so input is X and input is Y. So what I will do, I will make it truth table. Which single logic gate placed between X and Y and out would have the same effect as the network? Okay, so let me show you. Okay, so for these are NOT gates, and this is an OR gate, and here we don't have that circle. Okay, so if the inputs at X and Y are 0, 0, 0, 1, 1, 0, 1, 1, because these are NOT gates, what they do, they invert it. So at the A, when here you have 0, when here you have 0, this will become 1 and 1. When here you have 0, here you have 1, this becomes 1 and 1, because basically this is inverting. Whatever is the input at X, the A will be opposite of that. The whatever is the input on Y, the B will be opposite of that. So when you have 1, 0, here you will have 0, 1. When you have 1, 1, here you will have 0, 0. Then this is OR gate. OR gate is like addition. So 1 plus 1, that will be 1. 1 plus 0, that will be 1. 0 plus 1, that is 1. 0 plus 0, that will be 0. So remember this truth table. So the D option there, that is a NAND gate. Here you have an AND gate, and then you have a NOR gate in front of it. So if I try to make its, the truth table, so 0, 0, and you multiply them. AND gate is like multiplication. So 0 multiplied 0 is 0. So then you have to invert. That means it's a NOT gate. So you invert it. So whatever is the answer, 0 multiplied 0 is 0, and then you invert it. So you get 1. 1 multiplied 1 is 0. So invert it, and the answer is 1. So 1 multiplied 0 is 0, invert it and you get 1. So 1 multiplied 1 is 1, you invert it and the 0 is the output. If you look at their truth tables, both the truth tables, let me reduce more. If you look at both the truth tables, these are the inputs, they are same. The outputs are also same. So this can be replaced with this. This is a NAND gate. AND gate, and then in front of it, you have a NOT gate. So if you look at the options, D is the option, sir. It's not an easy question. Question number 33, D is the option, sir. This electronic from the O levels course, this has been taken out, and this topic electronics has been taken out from the Cambridge O level syllabus. So question number 33, this is the D is the option, sir. Okay, question number 34. The diagram represents a transformer. So here we have a primary coil, here we have secondary coil. This is the core. The core is made of the soft iron, and these coils, these bands, these coils, they are made of the copper. So the core is, which row shows material suitable for making the core and the primary coil? The core is made of the soft iron, and the primary coil is made of the copper. So I think directly A is the answer, sir. Question number 34, A is the right option, sir. Question number 35, he says the diagram shows the magnetic field lines around a wire carrying a current I. Which diagrams are correct? Okay, so if you want to find out the circular magnetic field around the current carrying conductor, we use the right hand rule. So you, for the straight conductor, you hold your straight conductor in your right hand in such a way that your thumb is in the direction of the conventional current. Then the curls of the fingers of your right hand are showing the direction of the magnetic field. So when I'm working on the first diagram. So number one diagram, my thumb is upward. Okay. So my fingers are telling me that it should be anti-clockwise, and you can see that they are anti-clockwise. Okay, so this diagram seems to be good. Okay, if you look at this diagram, the current is going upward in that conductor. Okay, so the magnetic field around it should be anti-clockwise. So on these sides it is anti-clockwise, but on these side it is clockwise. So this is not right answer. Okay, not right. Here the current is going downward. Okay, so conventional current is going downward. I will hold this in my right hand in such a way my thumb is pointing, is along the conventional current, and then the curves of my finger will be telling me the direction of the magnetic field, and they should be clockwise. Okay, in this diagram, the magnetic field is clockwise, and this diagram seems to be good to me. In this diagram, again, the direction of the current is going downward. Okay, hold it in your right hand in such a way that your thumb is along the conventional current. Then the curves of your finger are telling you the direction of the magnetic field. It should be clockwise, and they are they are not clockwise, they are anti-clockwise. So this diagram is basically wrong. So only the diagram 1 and 3 is right. What do you say? 1 and 3 diagram looks right to me, sir. So I think D is the option, 1 and 3. Question number 35, D is the right option, sir. Okay, so next question is question number 36, which is on your screen. Which statement about electromagnetic induction is correct? A conductor moving parallel to the magnetic uh, field lines induces an electromotive force in the conductor. When you move parallel to the magnetic field, no EMF is induced. Okay, you have to cut the magnetic field lines. The direction of the induced EMF opposes the change which produces it. This is the Lenz's law statement, and this is right statement, sir. This is the Lenz's law about the electromagnetic induction. The induced current is in a direction parallel to the direction of the motion producing it. We don't know that. The induced electromotive force decreases when the speed of the conductor moving across the field lines increases. No. When you move faster, the EMF induced is also larger. So D is wrong, sir. B statement is the perfect statement. That is the Lenz's laws statement. So I think B is the right answer. Question number 36. B is the right statement, sir. Question number 37. A very important experiment increased the scientists' understanding of the structure of matter. In the experiment, particles scattered as they passed through a thin metal foil. Which particles were used and to which conclusion did the experiment lead? They bombarded a gold foil with alpha particles, and most of the alpha particles went straight, and from there, they concluded that most of the atom is empty and there is a very small nucleus inside the atom. Okay, so alpha particles have a very small, atoms have a very small nucleus. Yes, this is that famous Geiger and Marson experiment, which we call the in which they discovered this nucleus. B looks the right option, sir. Question number 37, B is the answer. Question number 38, polonium PO has a proton number equals to 84 and a nucleon number equals to 218. Polonium changes into astatine by emitting a beta particle. You know, whenever a beta particle is given out, the daughter nucleus proton number is one more as compared to the parent nucleus, and its nucleon number do not change. Okay, so here you see the proton number has increased by 1 and the nucleon number has not changed. So this is the right statement. You know, this proton number thing is always written at the bottom and the nucleon number is written on the top. That's why this is not the answer. C is the right option. Question number 38. C. Question number 38, C is the right option, sir. I hope you understand whenever a beta decay happens, the daughter nucleus proton number is one more than the proton number of the parent nucleus. And the nucleon number of the daughter nucleus and the nucleon number of the parent nucleus is same. This is beta decay. This is beta decay we are talking about. Okay, so then we have, here we have the question number 39. The graph shows how the count rate for a radioactive isotope changes with the time. So here you have the count rate, here you have the time. He says, what is the half-life of this isotope? You see what is the reading here right now? That is something like 53. And if you have the 53, it will be something like 26 something. So when the reading becomes 26, okay, so what here the reading becomes 26. So what is this value here? 2. So this happened in 2 seconds. So the half-life is 2 seconds. Half-life is the average time duration in which half of radioactive isotope decays. So its count rate was 53. When the count rate will become 26 point something, the time duration will be equals to the half-life. So what is the half-life here? 2 seconds. I hope you understand. So this is the point. And here we go. And that means this number. From 53, the reading will drop to 56 something, okay? So that time duration in which this happened, that is the half-life. So this happened in 2 seconds, so that's the half-life. A is the option, sir. Question number 39, A is the right option. So on your screen, question number 40, he says, what is the nature of the alpha emission? Alpha is like the nucleus of helium. It's not like the atom of helium. It's like nucleus of helium. it has two protons, it has two neutrons. So basically, it is positively charged particle. So I think C is the right option. So question number 40, C is the right option. So that's it. We are done with this paper. So my dear students, in this video, we have presented I have tried to present you the solution of this paper. This was October-November 2022 to 1 paper. I have tried my best to present you the solutions, the concepts, and one problem can be because we are preparing these videos for our students which are uh, going to appear in the Cambridge exam. So the level of concepts, we believe they have the basic concepts. That's why we do not go into too much explanation. Okay, so if you like this video, if you think this video is beneficial for you, and it can be beneficial for your class fellows or your junior students, please share the link of this video with your class fellows, with your junior students, with your teachers. And you see, when you do this, you help me to promote my channel. Please share the link of this video on your WhatsApp groups, in your Facebook, on your Twitter, on your Instagram, on your Snapchat, on your TikTok. When you will do this, you will be supporting my work. I think uh, these videos will be helpful for a lot of students. These videos will be helpful for a lot of parents, for a lot of teachers. So thank you very much for watching this video. Have a good day. God bless you all.